All right, so I think what's going to happen here, we have two sections left. So yeah, we can do this. So we'll do 13-7 today, 13-8 tomorrow, practice test Thursday, test on Friday. Okay? So we'll be good, especially because these are, this is pretty straightforward.
Wait, what did
You test on Friday. Practice test Thursday, test on Friday.
And then are we done for the year?
No, then like I said, we're just going to pick some random individual.
We do some geometry review on Thursday when we do
No.
the practice test, and we'll go over it at the class.
We'll go over it as a class on Thursday all day together. Yeah. Instead of wasting time where I pass it out to you and you
So
pretend
this
to
is
work
our
on
last
it.
assignment?
No, there's two more left. And then there's going to be more assignments next
No,
week.
but I mean, like, we have this assignment, and tomorrow we'll get the practice test, and then we'll go
No,
over
this
it.
assignment and then
Isn't the date that are used for?
translating functions. Here's what it's all about. We've done this a billion times before already, so it's really easy to do. If we start with the sine function, what we're going to do is we are going to add a number onto that. And you already know what will happen when we do that.
It'll move up 3.
Yep, that moves the graph up 3. Or we could get crazy and subtract something.
Down.
And that would move the graph down. Right, so if I add or subtract something onto the end of the function, that moves it up or down. We've talked about that quite a bit before. Okay, and then if I, let's go cosine here just for funsies. If I go the cosine of x minus 4, or it would more likely be, let me change that before you write it down, cosine of x minus pi, what does that do? It translates it to the right, okay? Because inside the parentheses is opposite, so this is going to move the graph to the right pi units. And you probably don't need to write this down, but I will just to make sure I'm being super thorough. If I go plus pi over 2, then that's going to move the graph.
What's that bottom number?
Pi over 2.
Left pi over 2, okay? So all the same rules that we did with cubic functions or exponential functions or any of those functions hold the same with these guys.
Before the
Yeah, and we've already talked about that. Taylor asks a very good question. One of the things that we have seemingly skipped right now is what happens if I put a number in front of the cosine. What will that do? Nope. It changes the amplitude, right? We already kind of talked about that. The number in front will change the amplitude. If I go 2 cosine, that'll be a vertical stretch of 2. So instead of going in between -1 and 1, it'll go in between -2 and 2. Same thing if we put a number in front of the variable. We've already talked about that a lot. That changes the period. It stretches or shrinks it this way. Okay? So those are...
Could you restate that again?
how about if I restate it as an example?
Alright.
So,
After a hot, sweaty summer practice.
okay, so this is the whole entire thing put together. And this holds true for either a sine function or a cosine function. I'm just going to use sine function because whatever. A is the what? Amplitude.
Why are you doing the bar?
Because it's really the absolute value of A because it can be negative, right?
Yeah.
Right? B tells us, I should go 2 pi over b tells us the period of the function.
2 pi over 2? Yeah.
Uh-huh. H is the vertical, no, horizontal shift, right? I get vertical and horizontal mixed up a lot.
Well, it is an H.
I think a vertical is how high you can jump. But I have to think about it in my head. I think a vertical height. Okay, so this is the Kendra Warnock summary. She always likes the concise everything. So here's everything you need to know and more. And again, this is for either sine or cosine.
Hi, Kendra.
Oh, what are the chances? All right, so let's try one of these. And this is going to be a little bit gross.
So our amplitude is wait, don't start yet.
This is not going to be pretty, mostly because of the pi being hard for people
Period will
to
be pi.
understand. What?
Period will be pi.
Okay, so the first thing that you might notice about the graph of this function is that the period is going to be 2 pi over 2, which is pi. Is everybody good with that?
Yeah.
Okay. Then, then the amplitude is 1, right? Because there's a 1 in front of the thing,
Yeah.
but it's being moved down 1.5.
Wait.
So what I'm going to say next is that the range is going to be negative 2.5 to negative 0.5.
Hey, where did 2 pi over 2 come from?
Well, b is 2, because that's the number that's in front of the x.
Okay,
And the period is 2 pi over b, so 2 pi divided by 2 is pi.
Why is
Yes.
that?
Because what's the range usually?
Negative 1 to 1.
Okay, right. It's usually negative 1 to 1. So if I go negative 1 minus 1.5,
Oh.
that gives me negative 2.5. And if I go 1 minus 1.5, that gives me negative 0.5. Okay? So this graph is going to actually be entirely below the x-axis. Okay? Now because of that, one strategy that you can use to make it easier to graph is you can draw a dotted line in where the middle of it would be. Okay? Which would be at negative 1.5. And that has some fun name, that's some axis of something or something. Okay? So this is kind of going to act as our x-axis, even though the x-axis is really up here. Does that make sense? Okay, so we know that it's going to be bouncing around like that. Okay, so now we're good except for this phase shift to pi over 3.
Which means it shifts to the
Okay,
right.
so I don't know what they want us to do here. Oh, they want to go from 0 to 2 pi. Okay, so if I make the regular marks in here, 2 pi, pi over 2, and 3 pi over 2, which you normally use to graph your sine function, those aren't really going to be where the fun things are happening, are they?
No.
Okay? Because instead of starting at 0, since it shifted pi over 3 to the right, it's actually going to start at
1.5.
pi over 3.
How do we know
Okay? Which means that I need to add pi over 3 onto all of these things to find out where the real maximum and minimums and zeros are actually happening. Okay? So what's pi over 2 plus pi over 3? Does anybody know?
5 or 6.
5 pi over 6.
Wait, you have to give us a chance.
Okay? What is pi plus pi over 3?
Okay, where's this 6 pi coming from?
What is pi plus pi over 3?
6 pi over
3 pi.
pi plus pi over 3 is 4 pi over 3. So that's going to be somewhere over here. Okay? And then 3 pi over 2 plus pi over 3, what's my common denominator there? 6. So this is going to be like 9 pi over 6 plus 2 pi over 6. So that's a total of 11 pi over 6. What?
Wait, what is
No, I like what I got going here. Okay? So 11 pi over 6. Hey, boys. Hey, my goodness. There's no way you're going to know how to do this on your own if you're not paying attention right now. 0 chance. I don't care. 0 chance. Right here. So 11 pi over 6 is just short of the 2 pi mark. Okay? So the graph then looks like this. It starts at pi over 3, like we said, instead of 0. What's that? And it goes up. And this point right here, where it normally would have had a maximum at pi over 2, now it's going to have a maximum at 5 pi over 6, right?
Oh, yeah.
No, I feel like I'm doing this wrong. I am doing this wrong.
No, you're not. That was right.
No, I am doing it wrong because the period is only pi. So it's got to complete a whole thing in pi. So I'm going to draw what it would have looked like regularly.
We need all the in-betweens.
So regularly, since it had a period of pi, it would have looked like this. Does that make sense?
Yeah.
Okay? And so now the whole thing is just shifted to the right, pi over 3. If only you had a fun board like this.
We don't have the thing.
This hasn't been working out for me. There we go.
You're taking the line,
I took a line.
That's close enough. It doesn't matter.
Okay, so now it's shifted over from that. Okay, never mind. Does that make sense? So it normally started at 0, had a maximum of pi over 2. I'm sorry, crossed at pi over 2, and then came back up at pi because it did a complete cycle in the interval 0 to pi.
Yeah.
Okay.
So that's what we should draw right there.
So well, then we have to finish this because it's also going to do the same thing
Do we start
over
at
here.
-0.5?
What's that?
Do we start at -0.5?
No, that's its high point. It's going to be at -0.5, and its low point
Or
is
I
at.
mean -1.
Yeah.
So we start at -2.
Yeah, because that's right in the middle. Okay? So it's going to look something like that. All right? Which I know is tricky. I know that's a lot. And we'll do another example for you. But that's how that goes. Okay? Going to try another one? These are a little bit of a struggle.
Can we do a cosine one?
Sure. Okay, so what do you want to figure out first about this?
Hold on.
Period?
Okay, so period is 2 pi over pi over 2.
It's 2 pi over
Pi over 2.
pi over 2, which is 2 pi times 2 over pi. So the pi's cancel, so the period is 4. Okay? So maybe that'll be easier because we're not going to be messing with pi's and pi over 3s and 5 pi over 6s. We're just dealing with regular old numbers. So the period is 4. The amplitude is 2. But it's been shifted down 3, right? So instead of going between -2 and 2, if it's been shifted down 3, I have to subtract 3 from both of these. It's going to go from -5 to -1.
That's the range, isn't it?
That's the range, yep. You want to ask me how I got that?
No? No, fine.
Okay.
Gradually.
So just like I did before, I'm going to put a dotted line where the x-axis would kind of be. So what's right in between -5 and -1? -3. So I'm going to put a little axis here at -3. This right here is -1, and this right here is -5. Oh yeah, I remember helping my daughter with these. Mr. Helby has kids. You can also draw a dotted line where your maximum is going to be, and a dotted line where your minimum is going to be, if you want. It's going to bounce in between those things. So this, does that, I don't know if that helps you.
Yeah. I just didn't like the note.
What's that? Oh, okay. All right, so I'm not so concerned about making a graph from 0 to 2 pi. Let's just at least try and get one complete cycle of the function in here, okay? So since the period is 4, normally you go from 0 to 4, but the +1 does what? Moves it to the left 1. So I'm going to go from -1 over here to 3 right there, and just try and get in one cycle of the function.
Are we not using the dotted line?
Yep, we're going to use the dotted line. So let me extend this out a little bit so that it goes all the way to -1 and out that way. Okay? All right, so what points, what else do I have to put on my graph besides -1 and 3? I don't need anything below -1. Well, what's halfway between -1 and 3?
1.
1. And then halfway in between 1 and 3 is obviously 2. And halfway between -1 and 1 is 0. Okay? So it's going to start at the top because it's a cosine function. And it's going to complete one cycle in this interval from -1 to 3. So that means it has to start at the top, go down, and then come back up in that time frame.
Has to complete a whole cycle.
Has to complete one whole cycle.
It'll be at its minimum at 1.
So it'll be at its minimum at 1, and then it'll come up again and have a maximum at 3, like that. Okay? And if you really wanted to draw one between 0 and 2 pi, then you could repeat that again from 0 to 6, and you'd be good, but that's probably good enough for us. Okay? So I'll make sure to assign you a lot of these.
That's so nice.
Because they're very easy for you.
They're really nice.
Coach Aldrich, what does the -2 and the 2 have to do with?
What's that?
What is the answer?
-2 and 2 was what it originally was. And then when we went -3, we took and subtracted 3 for both of those. We moved them both down. Okay?